On a vast and prosperous farm, filled with fields that stretched as far as the eye could see, a peculiar tradition was observed every 10 years. The owner, a visionary who valued both innovation and the heritage of his ancestors, personally selected an earth measurer. This figure had the vital mission of mapping the farm in all its dimensions, from the expanses of its vast fields to the width of its winding rivers. However, a unique practice dominated this process. While the measurement of the vertical fields from north to south was done meticulously in meters, the measurement of the paths and rivers that ran from east to west was done in feet. This distinction, rooted in ancient customs, was accepted without question by the farm community. Curiously, the bridge that crossed the main river, flowing from north to south, measured exactly 30 meters in length. On the other hand, the path that cut through the farm from east to west, bordering fields and crossing woods, stretched for thousands of feet. The land measurer, equipped with a tape measure and a ruler in feet, went about this task with great diligence. However, during one of his surveys, an audacious idea occurred to him. Out of curiosity, he used his tape measure, usually reserved for north-south measurements, in an east-west direction. To his surprise, the tool proved to be just as effective as the ruler in feet. This moment of enlightenment made him question the need to stick to two different units of measurement for different directions. More profoundly, he discovered the exact relationship between meters and feet, an insight that challenged the logic behind the farm's bicentennial tradition. This revelation not only proposed a simplification in future measurement tasks, but also promoted a reflection on the importance of questioning and, where necessary, adapting traditions to contemporary knowledge and needs. Imagine that 1 foot is more or less equal to 30 centimeters. Now, you might be asking yourself, why are we talking about old farms, feet and meters in a subject about 4 dimensions and space-time? The point is that Albert Einstein, with his theory of relativity, showed something very interesting. He said that time, which we measure in seconds, and space, which we measure in feet or meters, but let's use feet to keep it simple, are not two completely separate things. In fact, physics starts to make a lot more sense when we think of time and space as parts of the same thing. So Einstein's relativity suggests that we live in a 4-dimensional universe. 3 of these dimensions are space, forward and backward, up and down and side to side, and the 4th dimension is time. This may sound a bit strange, but it's a way of understanding how the universe works in a more complete way. So when we talk about measuring things in feet and seconds, we're actually talking about how these measurements are connected in a very fundamental way to understanding the universe around us. Let's imagine you're in a car, or rather a spaceship, because let's take it to the next level, shall we? Now, let's say you're doing an experiment. It could be something simple like throwing a ball up and catching it. Whether you do it standing in traffic or zigzagging between the stars at the speed of light, believe it or not, the ball will behave in the same way. Doesn't that sound a bit crazy? Here's the first turning point. Einstein's theory of relativity, the one that turns your brain to mush if you think about it too much, has this concept called the principle of relativity. This basically says that it doesn't matter whether you're sitting calmly on your balcony or gliding through outer space. Physical experiments will turn out the same. This means that, according to the laws of physics, your speed is, in a way, a closely guarded secret. The universe won't give away its game that easily. But why complicate things with 4 dimensions when 3 are hard enough to understand? Ah, my friend, this is where it gets good. Einstein threw us for a loop because, by adding time as a 4th dimension, he showed us that space and time are so intertwined that they are practically inseparable. This not only changes the way we see the universe, but also how we understand our own existence within it. Have you ever stopped to think about how we measure the speed of everything around us? Let's use the car as an example. You're there, driving, and the speedometer shows your speed in relation to the ground. But here's a curious fact. This speed is always relative. That's right. There is no such thing as an absolute speed in the universe. That's the moment Einstein gave us with his first principle of relativity. But wait, there's more. The second principle, inspired by the experiments of two guys called Michelson and Morley, is about the speed of light. Get ready, because this will blow your mind. The speed of light is the same for everyone, no matter if you're standing still, running, or flying in a spaceship at thousands of miles per hour. This means that if you turn on a flashlight, light will travel at an incredible 186,282 miles per second. That's the conversion of 299,792, 558 meters per second to keep everything on an even keel. And if you're in a spaceship traveling super fast and you turn on that same flashlight, the light will still travel at the same speed. Now, why is this super important? Because this constant of nature shows us that time and space are flexible. In order for the speed of light to remain the same for everyone, space can shrink and time can expand or contract, depending on how fast you're moving. Let's use an example. Imagine an astronaut in a spaceship going super fast and you're here on Earth. If you both try to measure the speed of light, you'll come up with the same magic number of 186,000 miles per second. But here's the trick. You'll disagree about how far the light has traveled and how long it took to get there. To the astronaut, distances seem shorter. This is what we call space contraction, and time seems to pass more slowly. This is time dilation. It's like a magic trick of the universe, where space can stretch and time can slow down, all to keep the speed of light at its constant, unalterable pace. But here comes the twist. In order for this speed of light to be constant for everyone, Einstein tells us that space can shrink and time can stretch. It's as if the universe had its own photo editing app, but for reality. So, what we think is solid and unshakable, space and time, is actually quite flexible. Now, let's add a little spice to this story. If space and time are so flexible, how can we measure anything reliably? Einstein had a brilliant insight. Why not use the speed of light as a cosmic ruler? That's right, instead of talking about meters and seconds separately, why not think of them as two sides of the same coin? 1 second in this crazy universe is equivalent to the distance light travels in 1 second, about 186,282 miles. Now take that concept and apply it to everything. When we measure the distance between two events in space-time, we use something called an interval, which takes into account both the distance in space and the difference in time. It's as if the universe has given us a magic tool to agree on how far apart things are and how long they take, even when everything else seems to be in flux. So the next time you look at the stars, remember, you're seeing not just space, but space-time, the fundamental structure of our universe. So what would you do if you could travel at the speed of light?